Good morning, guys, and welcome back. What we are actually going to get into today is Chapter 11. Chapter 11 is a fairly short chapter, and this is going to be our last chapter of the year. So today we're going to address 11.1, 11.2, and 11.5, and you'll eventually have a quiz on this. And then our last section will be 11.4, which you won't have a quiz on. But then our last day of the marking period, either the 16th or 17th, you will have a test on Chapter 11, last test grade of the marking period. Okay, so that's kind of where we're going. But for today, let us start with 11.1, 11.2, and 11.5, which is all about, as you can see, areas. So areas of polygons. Now, many of these areas you already know. So just like area of any parallelogram is base times height, or a lot of you know it as length times width. Area of a triangle, 1/2 base times height, or base times height divided by 2. Trapezoids, so they have like a B1 and B2. B1 is base 1, B2 is base 2, and then we have the height. So the formula is 1/2 times the height, and then in parentheses you're going to have times B1 plus B2. And then last but not least, the one that's a little bit new for you probably is the rhombi and kites. Their area is 1/2 D1 times D2. And D1 and D2, I like to think of them as diagonal 1 and diagonal 2. So now some of these can be really easy. If they give you the components, the base, the height, base 1, base 2, D1, D2, then it's really easy. You just plug in. And sometimes they may be a little more challenging. Maybe you have to solve for a side first using trig or special right triangles, and then plug in to find the rest. So let's look at an example. So example 1 says find the area of the parallelogram. So if it's a parallelogram, we know, looking back, that our area is simply base times height. Now if you look, we want the length of the bottom is going to be the base. So we have the base is equal to 12.8. But our issue is that we do not have the height. We have this length over here, but that is not the height. Remember, height is always like altitude. So the piece that I just outlined in red with the right angle is our height. That is what we need to find. So we're actually going to use this triangle here to help us solve for our height. I'm going to call it H. So if we look at that triangle, what we can see is they actually label one of the angles as 45. We know that this angle has to be 90, so that means that the third angle down here is 45. So we get a 45, 45, 90 triangle. And if you have to look back at your rules when it comes to 45, 45, 90, and this should be pointing at the angle here, we know that it's going to be leg times square root of 2 equals our hypotenuse. And the piece that we are given here, our 6.4, is our hypotenuse. So let's solve for it. So our hypotenuse, let me just write it down here, hypotenuse equals leg times square root of 2. Our hypotenuse is 6.4 equals, our leg is what we're trying to solve for because we're trying to find the height here. It's our height times square root of 2. Now how do we solve for H? Divide both sides by square root of 2. So 6.4 divided by square root of 2. I'm calling it H. In this case, H is 4.53. Okay, so that is our height. If they gave me two sides, I could use Pythagorean theorem. I could even use trig here if you wanted to. You would have to use, the sine or the cosine function if you want to do it that way. Or you can use your special right triangles as long as it's 45, 45, 90, or 30, 60, 90. So now that I have H, I have the base, and I have the height. So now all we're going to do is plug in area equals base times height. Base is 12.8. Height is, in this case, 4.53. So our area is going to be 57.93 inches squared. Okay? So they can be long problems, but they can be quick. Once again, I do not put the try problems in these notes, but they are in the worked out notes, so you can go and try one out. I think the try problem for this one uses 30, 60, 90. Okay, our next problem, what we have, is we are going to find the area of the triangle. So, just like a parallelogram, this involves the base and the height, but instead it's 1/2 base times height. So let's see what we have. In this case, we have the height, but we do not know the base. So the base is what is unknown to us. So here's what we're going to have to do here. What they do is they give us one angle of 40. We know that this is 90. So we are going to actually use trig to solve for the base. But we can't just solve for the whole base. So what we're going to do is we're going to solve for this piece of the base first. I'll call it y. And then I'll solve for the second piece of the base, and that will give me x. And I'll use trig one time, and then I can just use Pythagorean theorem. So let's look at how we do this. So if I pull apart this first triangle, what I'm going to see is the height is 13, I have a 40-degree angle, and I want to solve for the bottom. So let's think. If we think back to SOHCAHTOA, in regards to that angle, the 13 is the opposite. The y is my adjacent side. So I'm going to use tangent. So tangent of 40 degrees, remember you're going to use your tangent button, is equal to opposite over adjacent. And I'm going to cross multiply and solve. And I will get that y is equal to 15.49. Be careful when you cross multiply, put that tangent of 40 over 1, cross multiply, divide, and solve. I will get y is 15.49. Okay? What's nice is to find the bottom, so this piece is 15.49. To find the other piece, x, for our right triangle, if you notice, we can just simply use Pythagorean theorem. 13 squared plus x squared equals 17 squared. And if we solve, we'll get x is equal to 10.95. So what's nice is use your old tools here. Use Pythagorean theorem, use trig, use special right triangles. If this was a 30 degree instead of 40 degree, I would go straight to 30, 60, 90 triangle rules. Okay? So now if you notice, the second piece of our base is 10.95. So that's going to make our entire base 26.44. So that is our base. Our height is 13. So area is equal to 1/2 base times height. Area is equal to 1/2. Base is 26.44 times our height, which is 13. It's getting a little cut off there. Let's see. There we go, times 13. So our area is going to be equal to 171.86 inches squared. Okay, so take it piece by piece by piece. And if you're, for something like this, trying to solve the large triangle, you can't use, so say if I'm focusing on this large triangle here, it's not a right triangle. So you can't use trig here. The only thing you could try to use would be like law of sines and cosines, but a lot of times it's just easier to use regular trig, 30, 60, 90, or Pythagorean theorem. But like I said, once you have the pieces, the base and the height, plugging in and finding the actual area is the easy part. Okay, let's keep going. So we found the area of a parallelogram and we found the area of a triangle. What about a trapezoid? So this is an example when they give you everything you need. When it comes to a trapezoid, it does not matter what you call base 1 and what you call base 2. And the height is always the piece in between the two bases. Okay? Now, your base 1 and base 2 will never ever be the sides that I outlined in red. They will always be the sides that are parallel to each other. And I think we talked about this when we talked about trapezoids a little bit. So it will always be the sides that are parallel to each other are going to be the bases. So base 1, base 2, and the height. So what is our formula? area equals 1/2 times h times base 1 plus base 2. Make sure you put them in parentheses. So what am I going to do? Well, I'm going to plug in my pieces. My area is equal to 1/2, my height is 12, and then base 1 plus base 2 would be 16 plus 6. Make sure they are in parentheses. I'm going to clean it up before I even plug in. So it would be 1/2, 12, times 16 plus 6 is 22. Multiply this all out, I'll get that my area of my trapezoid is 132 feet squared. So when they give me the pieces, just make sure you use parentheses. It's pretty easy to plug in. And all of these area formulas are right on that first page for you to refer to. You can also look at the worked out notes, like I said, they'll be on there for you to look at. Okay. Example 4, find the area of the rhombus. So last but not least, we have our rhombus. Rhombus area is equal to 1/2 d1 times d2. Okay, and it's simply put, I call d1 and d2, they're referred to that because they're the diagonals. My one diagonal in this case is going across. That length they tell me is 18. My other is 10. So d1 is 10. D2 is 18. You're going to multiply them, so it does not matter which one you call D1 and which one you call D2. So my area would just be 1/2 D1 times 10 times D2, which is 18. So 1/2 of 180 is just 90 meters squared. And get used to using labels. Okay, and that is your last area. The other little piece, that 11.1, 11.2, and 11.5, I should say in these sections that we talk about, is area of similar figures. If two polygons are similar, then the ratio of their areas is the square of the scale factor. So this basically means if my scale factor is a to b, my ratio of my areas from one figure to another is a squared to b squared. And I believe when we talked about 11.3, we referred to this a little bit in the last chapter. Let's go forward and see how we use this. So it says, where are we? In example 6, triangle JKL is similar. Remember, this little symbol means similar. And if anyone remembers, if we were in class, I would say, does anyone remember what similar means? And I would hope that we would kind of remember it means the same shape, but not exactly the same size. And I think when we started learning similarity, I showed you the duck video, the rubber duck video, and how the ducks were, the same type of duck, but just getting bigger and bigger and bigger. But that's what similar means. So these two triangles are similar, meaning that they have a scale factor, and the area of the one triangle is 30 inches squared. So the area of triangle JKL is 30. Okay? It then says find the scale factor and the area of triangle PQR. So the scale factor should not be hard here, because what we are going to do is we're going to look and we're going to find two corresponding side lengths. You want to go by the similarity statement. So our similarity statement says triangle JKL is similar to triangle PQR. So if we look at this, the only side length I have on triangle JKL is JL. So if I'm going to use side JL, that's going to be similar to side length PR. And if you look, that is the other side they gave us. When you're writing a scale factor, if you remember this from what we did, it's just a ratio of side lengths. So I'm going to go from larger to smaller. So my scale factor here would just be 15 over 12. And you can reduce it to 5 over 4. So this is going to be my scale factor, and this is the first part of that answer. We want the scale factor and the area of PQR. So this is my scale factor. This is something we talked about, something you guys should be a little familiar with. Now let's get into the new stuff. It says if my scale factor is A to B, then the ratio of my areas is A squared to B squared. So this means what I can do, it's actually lending me to set up a proportion. So what is my proportion going to be? The ratio of my areas is equal to my two scale factors squared. So I don't know my area of PQR. That's what I'm trying to find. I'm going to call that X. But I do have my area of JKL. So my area of PQR divided by my area of JKL is equal to the ratio of my scale factors squared. So my scale factor squared here is A squared, so it's going to be 5 squared over 4 squared. Okay, so we're referring directly to this formula that says if I take my scale factor, if my scale factor is A to B, my ratio of my areas is A squared to B squared. So A squared to B squared is 5 squared to 4 squared is equal to my X over 30. Watch the order you go in. If you notice when I wrote my scale factor, I went from PQR to JKL. So that way when I wrote my area, I went from PQR to JKL. And all you're going to do is just simplify and solve this. So I'm going to solve this to the left, change my color. So we're going to get 25 over 16 equals X over 30. You're going to cross multiply and solve, and you'll get that X is equal to 46.875 inches squared. And remember, what is X? X is the area of PQR. So I found the area and I found the scale factor. Like I said, the biggest thing here is just watch your order. If I would have went from JKL to PQR, I would have then went 4 squared to 5 squared equals 30 over X. You'll still get the same answer, just be careful. Okay, and for our last example for the day, example 7 says the figures are similar. So they're giving you two figures, okay? Find the scale factor of blue to green, so they're giving you the order, and find the value of X. So if you notice in this case, this one's a little different because they're giving you both of the areas, and they're also giving you one side length but not the other. They're asking you to still find the scale factor. So let's think about this. If they're giving me the areas, I know the areas are, the ratio of the areas is A squared to B squared, right? Where A to B is the scale factor. So I want to find the scale factor from blue to green. So in this case, I'm going to call blue A. So, and green is going to be my B in this case if I'm thinking about scale factor. So my ratio of my areas is A squared to B squared. So this means A squared is equal to 400 over B squared is equal to 64. But I want the scale factor. The scale factor, I want to take A squared and B squared, and I want to get A and B. So how do I do that? I'm just going to take the square root of each one. So the square root of 400, square root of 64, that gets me that will get me square root of 400 is 20, square root of 64 is 8, and in the end, this reduces to my scale factor of 5/2. Okay, and I went from blue to green because I put the area of blue on top. So again, my ratio of my areas is my scale factor squared. So I take my ratio of my areas, I divide my areas, 400 over 64, and before I divide them, I'm just going to take the square root of each piece to get me my scale factor. So if, for example, my areas instead were 144 and, 16, I'm going to do the same thing, 144 over 16. I'll take the square root. This will get me my scale factors, and then I'll clean it up. Okay? Do not clean it up until after you find your scale factor. When you think about it here, all you're really doing is either squaring your scale factor to get your ratio of your areas, or square rooting your ratio of your areas to get your scale factor. Now, once I have my scale factor, what do we need to do from here? We need to find the value of X. This is pretty simple, so we no longer need our areas because we know that our scale factor of 5/2 is equal to the ratio of corresponding side lengths. So it would be equal to 40 over x. We could cross multiply. We'll get 5x equals 80. So x will equal 16, and I believe it is in millimeters. Okay, so that is the last example. It all comes back to here. If my scale factor is a to b, to find the ratio of my areas, what I would do is I would square each one. On the other hand, if I'm given my ratio of my areas and I want to find my scale factor, I'm going to square root each one, and that will get me my scale factor. And pretty much I'll just be setting up proportions in this case. So this is 11.1, 11.2, and 11.5. Those are our examples for today. You're going to want to go do your lesson check, and then of course you'll have a homework assignment. And so you'll probably have a quiz in 3 class periods or so. That will be your last quiz grade of the marking period. You're not going to have a quiz on 11.4. And I just wanted to say that I miss you guys. Keep up the good work. A lot of you are working so hard. If you're missing an assignments, go back and feel free to do them for some credit. But just keep up the good work. If you have questions, please reach out. Please continue to watch these videos to prepare for next year. Okay? Like I said, let me know. Look out over the worked out notes to see if you have any questions.